Okay guys, we're looking at the sequences quiz review. Remember, this is going to be our quiz that we're going to take on Tuesday of next week. So make sure you get ready for this. If you can do these two packets for this review, you are more than ready for the quiz. Okay, so let's take a look. So I'm only going to pick a few from each section because they're very similar to each other. So the first question says, list the first 5 terms of each sequence. Identify the sequence as either arithmetic, geometric, or neither. So remember, arithmetic is addition or subtraction, and geometric is multiplication or division. Okay, so I'm going to pick the more difficult one, which is probably the first one, because there's 2 n's going on. Now remember that n stands for the term number. So if I want to find the first term, I need to find where 1 is plugged in for n. So it's 2 times 1 squared plus 1. Now what I want you to notice is how 1 is going in for both n in the first part and n in the second part. It's replacing both of them. Let's simplify, and we get 2 times 1, which is 2, because 1 squared is 1, times 2 is 2, plus that 1 gives me 3. So my first term is 3. Here we go, a sub 2, which is the second term. So I'm going to plug 2 wherever I see an n in for both spots. Okay, 2 squared is 4 times 2 gives me 8 plus 2, which is 10. Remember, you have to do order of operations first, so 2 squared and then multiplied by 2, and then plus 4. So the second term is actually 10. Okay, that's to 0, sorry. The third term, same process, just over and over again, 2. Now I'm plugging 3 in for n. Okay, so order of operations says I do 3 squared first, which is 9. 9 times 2 is 18, plus 3 is 21. Okay, so the third term is 21. The fourth term follows the same property. I'm plugging 4 in wherever I see an n. Order of operations, 4 squared is 16, times 2 is 32, plus 4 is 36. Okay, and the last one is the fifth term. So we have 2 times 5, because 5 is going in for n, squared, plus 5. Order of operations, 5 squared is 25, times 2, which is 50, plus 5, which is 55. Okay, so our last term is 55. So remember, we plug in whatever number we're looking for that term number. Okay, so if I follow this pattern, I still need to know, is it arithmetic, geometric, or neither? So 3 to get to 10, I'd have to multiply by 7, okay? Add 7, and then if I add 7 again, I get 17, so that doesn't work. Multiplication, I'd have to multiply by some fraction to get to 10, and then the same fraction would not, it would not give me 21. So there is not a pattern, or arithmetic or geometric. Question 3. Okay, I'm going to show you how to do this. You are given 3 sequences below. Determine whether the formula is arithmetic, geometric, or neither. Justify. Okay, so I'm going to pick questions B or C. For A, you just have to look for the pattern. We've done these multiple times before, but for B and C, it's a little more difficult because there's n involved. There's actually a formula or a function for it. So if I want to figure out the pattern, I could look at the actual equation and see, oh, what does that look like? Or I could find a few terms. If I find the first 3 terms and I don't see a pattern in the first 3 terms, then there's not going to be a pattern in the entire sequence. So use the skill we just learned above. If I'm trying to find the first term, plug in 1 for n. So 1 over 1 squared, which is 1 over 1, which just simplifies to 1. So my first term is 1. Now I'll do 2. 1 over 2 squared. Well, 2 squared is 4, so 1 over 4. I'll do 3. 1 over 3 squared, which is 1 over 9. So how can I get from 1 to 1/4? I can multiply by 1/4. But then if I multiply 1/4 times 1/4, see if that pattern continues. 1/4 times 1/4 is actually 1/16, and that is not what we have here for my third term, so 1 over 9. So because there's no pattern arithmetically or geometrically, it's going to be neither. Okay, so an easy way to figure it out is just to find the first few terms. Follow the pattern. Where in C, same idea. Find the first few terms and try to figure it out. Okay, next questions. Okay, for the second page, I want to do a multiple problems here, so I really want you to figure this out. First part, question 4 and 5, says for each sequence, find the explicit formula, and then after that, find the 10th term. So I first need to figure out the pattern. Okay, and I don't even know if it's geometric or arithmetic, so let's figure it out. To get from 2 to 6, I could multiply by 3, but then 6 times 3 would give me 18, so it's not geometric. What about arithmetic, so addition or subtraction? 2 plus 4 gives me 6, plus 4 gives me 10, plus 4, there we go. So it's got to be arithmetic. So if I want to set up my arithmetic formula, a sub n equals a sub 1 plus d times the quantity n minus 1. Remember, those are on our first page. We already wrote them down. The two parts that I need are a sub 1 and my common difference. And then I can have my formula. Well, a sub 1 is clear because it's the first term given. And the common difference was we added 4 each time. And there's my explicit formula. Okay, and then it says find the 10th term. Well, n stands for term number, so I'm just going to plug 10 in for n. Okay, so let's simplify what we got, and that's our 10th term. I got to do what's in parentheses first. So 10 minus 1 is 9. 4 times 9 by order of operations gives me 36. 36 plus 2 is 38. So that 10th term is 38. Okay, question 5. Let's try arithmetic first. 5 plus 15 is 20, but then plus 15 is 35, so it's not arithmetic. Let's try geometric. 5 times 4 gives me 20, times 4 gives me 80. There we go. So multiplication by 4. Okay, so we got to use our geometric formula, which is still on the first page as well. Okay, oh, I mixed it up a little bit. Let me get back here. Okay, so sorry about that. It is a sub 1 times r to the n minus 1. So all I need is that first term and the common ratio. Well, the first term is 5, and we multiplied by 4 each time. And now it says find the 10th term. It's going to be kind of crazy here. So give me a second. Remember, you can just plug this right into your calculator. 5 times 4, and then I'm plugging 10 into my calculator. 10 and okay, this is a big number here. So 10 minus 1, the exponent first, is 9. 4 to the 9th is 262,144. Multiply that by 5, which is that first number, and we have our 10th term, which is pretty crazy. 1,310,720. I know that seems huge, but think about what's happening here. We're multiplying by 4 9 times over. That's going to be a huge number. Okay, question 6. Given the recursive formula, find the first 5 terms. Hint, 1's already given to you. Remember that a sub n stands for any term, so a sub 1 stands for the first term. Okay, so this formula tells me that I'm going to take, if I want to find the next term, I have to take the term before it and multiply by 1/3. So take 1/3 of 27, which is 9. Take 1/3 of 9, which is 3. Take 1/3 of 3, which is 1. You can just be multiplying by 1/3 on your calculator and multiply by 1/3 one more time, and you get 1/3. But now it says write the explicit. Well, notice how we're multiplying over and over and over. So this is my constant ratio, my common ratio right here. And my first term was already given to me. So the explicit formula, all I need is the first term, which was given. I need the common ratio, which goes in the parentheses, which was also given. And I just raise to the n minus 1. And there you go. Okay, I'm going to do one of these. Given the two sequences below, write the explicit and recursive. So we'll start with explicit. Let's take on B. No, let's take on A. Okay, so I'm starting from 1. To get to -2, I could multiply by -2. Then if I multiply by -2, I get +4. So it's not geometric. I could subtract 3, subtract 3, subtract 3. So my pattern is subtracting 3 over and over again. So that means it's arithmetic, because I'm subtracting over and over again. So my formula has to be the arithmetic formula. Well, a sub 1 was given to us with a +1. And I do plus the common difference, which is -3. I'm going to put that in parentheses because the negative. And then it's just n minus 1. Nice. The recursive formula, if I want to find the next term, I have to take the term before it, so it's going to be a to the n minus 1, and whatever that common difference is. In this case, it's subtracting 3, or you could do adding a -3, whatever you want to do. But to get the next term, I always subtract 3, subtract 3, subtract 3. And there you go. Last question. Mr. Kruger suffers from allergies. When allergy season arrives, his doctor recommends that he take 300 milligrams of his medication on the first day. So when I see first, I'm thinking A sub 1, that first term. Okay, first day. And decreases the dosage by 1/2 each day for 1 week. So I need to write an explicit formula. Okay, decreasing by 1/2. Well, if I start with 300 milligrams, if I want to take half of it, I could subtract 150. But then if I subtract 150 again, that's not taking half of 150. So it can't be arithmetic. It's got to be geometric. So if I want to think taking 1/2, that's the same as multiplying by 1/2 over and over and over again. Well, all I need are my first terms and my common ratio. So A sub n equals 300, which is my first term. In parentheses goes the common ratio. And then I raise to the n minus 1 power. And there you go, guys. Good luck.